Namaskar. Today's topic is Karst topography. The content of the topic is introduction, worldwide distribution, favorable conditions for the development of karst topography, characteristic landforms of karst regions, and finally the conclusions. Let us go by one. The introduction. The geological formations vary from place to place. Some contains heterogeneous rocks and some contains homogeneous rocks. In several parts of the world, the carbonate rocks exist over a vast regions. Limestones and dolomites are the dominant rocks of such regions. These areas show a typical topography resulting from the dissolution of surface rocks by surface water and subsurface rocks by groundwater. Such regions are called as karstic topography or karst region. In areas of limestone and dolomitic rocks, the solution action of underground water gives rise to a highly distinctive landforms both on land and below the surface. These features are collectively known as karst landforms. Karst is an Yugoslavian word. On the Adriatic coast in Yugoslavia and the adjoining areas of Italy, there is a limestone plateau known as Karst, which provides the best example of landforms produced by the solution action of groundwater. This action or this region is 500 kilometers long from northwest to southeast along the coast and is about 80 kilometers wide. The plateau is about 2,500 meters high above the sea level. Here, the surface drainage is almost completely absent. The surface is highly irregular, containing rocky waste riddled with innumerable holes, pits, and ravines. The term karst is a comprehensive term applied to limestone and dolomitic areas that possess a peculiar topography. The role of underground solution and the diversion of surface water to underground routes cause this topography. Or the term karst topography can be defined as a unique landforms produced by chemical weathering or chemical erosion of carbonate rocks. They constitute mainly a calcium carbonate, that is CaCO3, that is nothing but the limestones, and magnesium carbonate, that is dolomites, dissolved by surface and subsurface water, that is nothing but the groundwater. These are the unique geomorphic features. Let us coming to the worldwide distribution of karst areas. The karst topography generally develops in these areas where thick beds of massive limestones lie just below the layer of superficial materials. Besides, the karst topography also develops on dolomitic limestone and dolomites and chalks. The karst topography is well developed in Caucasus region of southern France, Andalusian regions of Spain, then Tabasco in Mexico, Jamaica, northern Puerto Rico, western Cuba, southern India and Virginia, then Tennessee and central Florida of the USA. These are the major karst regions. The minor karst areas are example the Carlsbad areas of USA, chalk areas of England and France, and parts of Jura mountains. In India, there is no properly identified limestone topography areas and studied because of non-existence of extensive thick limestone formations near the surface. Most of the limestone formations of Indian formations are buried under thick covers of sandstones and shales. Then coming to the favorable conditions for the development of karst topography. The following conditions are necessary for the development of karst topography. 1. First of all, the rock on and near the surface should be soluble in the ordinary rain or soil water. The most suitable rock for the purpose is limestone. Dolomite is also suitable to a great extent, but it is less soluble than limestone. Chalk is also soluble, but it does not possess some other attributes which are essential for the full development of this type of topography. Limestone must be massive thickly bedded, hard and tenacious, well cemented and well jointed. Number 2. Limestones should not be porous, wherein a permeability is largely controlled by joints and not by the mass of the rocks, because of limestones are porous. The water may pass through the rock mass, and thus the whole rock mass will become a weak and will porous and thinly bedded. Then water will infiltrate through a joint, resulting into effective corrosion of the limestones along the joints, and solutions holes would be formed. Number 3. The position of limestones should be above and ground table to the surface. Drainage may disappear through the sinks, blind valleys and sinking creeks to have a subterranean drainage, so that the cave, passage and gullies and associated features may be formed. Number 4. The limestones should be widely distributed in both areas and vertical dimensions. Number 5. The carbonate rocks should be very close to the ground surface, so that the rainwater may easily and quickly infiltrate into the beds of the rocks to form a solutional landforms. Number 6. The limestones should be highly folded, fractured and faulted. Number 7. There should be enough rainfall, so that the required amount of water is available to dissolve a carbonate rocks. Coming to the fourth module, that is characteristic landforms of karst regions. In limestone regions, various distinctive landforms develops mainly by the solution, which are not found in other areas. Some of the more important of these landforms are described below. One is terra rossa. When rainwater dissolves a part of surface rock and enters the subsurface particles of red clay soil are deposited on the surface as well as in the open joints. This is a terra rossa and very much resembles a lateritic soil. It may not be present on steep slopes, but can be seen in areas which are either flat or have a gentle slope. Sometimes it may be several feet thick and entirely covered by a rocky surface. Number 2. Lapis. Where the limestone surface is not covered with terra rossa and the surface is undulating, solution action of water tends to enlarge the rock joints downwards. This results in the formations of very rough topography, where the surface is cut into a narrow and deep surface, and it extends into a deep clefts between thin and needle-like pinnacles. The sharp pin-like vertical pinnacles are roughly or parallel to one another, and between them are found a narrow and deep trenches. They are respectively called as clints and gravats in England. For this kind of serrated landscape, in the French word lapis is used at the international level. In Germany, this kind of landform is called carene. On account of the existence of the lapis, the surface becomes so rough and intractable that it is impossible to walk on such a surface. Lapis, however, provides an excellent illustration of how the solubility of rocks, their permeability, joints, bedding planes and other physical and chemical attributes produce a differences in the rate of localization of solutions. Example of lapis abound in the Dalmatian karst regions. Number 3. Sinkholes and associated features. When a rainwater percolates into a limestone, it enters the rock joints and removes the soluble elements by solution. The joints increase in size by solution and provide even easier passage over the water. Thus, the prolonged solution results in the formations of holes along the joints, which are known as sinkholes. Topographically, a sinkhole is a depression, most commonly ranging in depth from 5 meters to 10 meters. These small holes are found in a large number in the karst regions, where sinkholes terrain is quite common. They are usually funnel shaped with rounded and open tops. Similar dry holes are met with in the chalk holes or the chalk areas of Britain, which are cylindrical and are called swallow holes, as these surface openings almost completely swallow the surface drainage during the rains. Depending on their mode of formation, sinkholes are divided into two classes, one which have been formed entirely by solution and the other which have been formed by slumping sinkholes formed in this fashion are called as collapse sinks, and their walls are usually steep and rocky. Then funnel shaped sinkholes formed by solution tend to enlarge downwards because of the repeated action of solution. In the Karst region of Yugoslavia, these enlarged funnel shaped sinkholes are called dolines. Here they are usually 5 meters to 25 meters deep and have a diameter of 10 to 100 meters. Very often the bottom of the dolines is closed as a result of the fall of debris from above, so that the water only percolates slowly instead of flowing down. As a result, water may accumulate in the dolines and form a small lakes called Karst lakes or sinkhole ponds, depending upon their size. Extensive depressions are called uolos, which are up to 1 kilometer across. They are formed in a number of ways. One, due to coalitions of several dolines. Number 2, due to continuous solution and enlargement of dolines. Number 3, due to collapse of upper roof and large cavities formed underground. Number 4, due to coalitions of various sinkholes. Depressions even larger in size than uolos, which owe their origin to solution of down-faulted or down-folded limestones blocks, have been called polje. It resembles an uolos in appearance, but differs in extent and origin. The areas of polje may cover a several square kilometer. The largest polje in Yugoslavia in the Western Balkans is the Livan polje, which have a 70 kilometers long and 5 to 10 kilometers wide. Valleys of Karst regions. The upper surface having several sinkholes in the regions of limestones, having horizontal beds of slightly inclined beds, is called Karst plain, on which a surface drainage system develops a various types of valleys and typical landforms. Sinking creek. The surface of the Karst plain looks like a sieve because of development of closely spaced numerous sinkholes. These sinkholes act as funnels because the surface water disappears through numerous sinkholes. The small streams lost their waters in one or more sinkholes and are thus called as sinking creeks. The sinking creeks may flow as underground streams for some distance before again appearing as a surface streams. Example, the Lost River in southern India, USA, flows underground for 13 kilometers before it again starts flowing on the surface. Blind valley, where the stream terminates in a sinkhole and thus the situation continues for a long time, the stream carves out a fairly Karst plain. Under such conditions, the river valley ends at the sink or swallow hollow and is called a blind valleys. During the rainy season, when the increased volume of water is not able to enter the sinkholes, the blind valley are converted into a temporary lakes due to the large accumulation of water. Karst valley or solution valleys. A special kind of blind valley different from the above described is also found in the Karst regions and is known as either Karst valley or solution valleys. In areas where the upper layer is composed of sandstones or shale and is underlined by limestone layer, the surface streams developed on the upper layer, and maybe of course the times it cut down to deep enough and start following on the limestone bed. In such a situation, the sandstone ridges may be found on both sides of the valleys, but the river flows in a deeply entrenched valleys on the limestone floor. Here, on account of the presence of limestone, the river develops the tendency to sink underground and abandon the surface routes in favor of underground ones. In limestone areas, after a long period of solutional erosion, some residual hills and hillocks remain which resembles the monadnocks and born halts. These rounded limestone hills rise from the Polje surface. They are known as humps in the Karst regions of Yugoslavia. They are known as Pepino hills or haystacks hills in the Puerto Rico and Magots in Cuba. Underground streams and caverns. Underground streams and caverns are the distinctive features of limestone regions. The caverns or the limestone regions. The caverns or cave is a subterranean hollow formed subsequently and essentially by the solutional and corrosional activity of underground water. In fact, the caves are the most significant landforms produced by erosional work, mainly corrosion and solution and abrasion of groundwater, especially in limestone lithology. Caves are vary in size and shape, ranging from smaller size to larger caves. The large caves are formed in the regions of pure massive and thickly bedded limestones. Various contrasting theories have been put forward by different geomorphologists to account for the origin and development of limestone caves. One is depositional landforms. Besides the solutional features, a variety of depositional features are formed on the floor or in the ceiling and the walls of the caverns, which greatly add to their beauty and interest. The cave travertine is a term which is collectively used for those depositional forms. When the underground water drips from the cavern ceiling, it contains carbonate of lime. When it develops develops in the form of droplets of water or hanging by the ceiling, some water is evaporated and portion of the carbonate of lime is deposited on the ceilings. This process is repeated with every fresh droplet of water, and the deposit of this type or deposit of lime goes on extending from the ceiling downwards. In course of time, this results in the formations of a long and thin column of carbonate of lime hanging downward from the ceilings. These are known as stalactites. They are wide along ceiling and tapering downwards. The drops of water which fall from the ceiling down to the floor and caverns also contains the carbonates of lime, and with every drop of water falling on the floor where there is some deposit of carbonate of lime, thus form a cavern's floor, also rises to pillar-like columns, which is known as stalagmites. Stalagmites are usually a broader but shorter in length than stalactites. Since the drops of water as they fall down get spattered on the floor, the base of the stalagmite is usually thick and wide, and its outline is not so symmetrical, though it tapers towards the top. Sometimes the stalactites growing downwards and the stalagmites growing upwards meet together and form a continuous column from the floor to ceiling and are known as columns and pillars. In addition to the above depositional features, there is found in some caves another depositional form known as helictite, which develops where the water entering the cave is not sufficient to give rise to a drop that falls, but only to keep the surface wet. Under such conditions, the helictite deposit does not necessarily extend along the vertical lines, but it may grow in any directions, depending upon the chance of orientation of the crystal axis of calcium carbonate. Therefore, they grow in all kinds of shape and size. In the karst regions of Yugoslavia, which provides an excellent example of the distinctive limestones topography, we find an extensive development of underground streams and caverns. The sinkholes which connects the caverns with the surface is called ponor. These are usually vertical or stair-like and sufficiently deep, and the caves are located at their bottoms. Underground caves are found in India in several limestone areas, but very few of them have been studied. They include the Jabalpur regions of Madhya Pradesh, the Rohtas plateau of Bihar, the Cherrapunji area of Meghalaya, Kurnool in Andhra Pradesh, and parts of Kashmir and other limestone areas. Various contrasting theories have been put forward by different geomorphologists to account for the origin and development of limestone caves. Two-cycle theory of Davis. In 1930, William Morris Davis put forward his two-cycle theory of cavern developments. Davis and his supporters, that is Bredge, have put forward the following arguments in support of the two-cycle theories. 1. A clear evidence of deep-seated solution below the water table are available from many karst regions. The caverns present three-dimensional network and sponge-like patterns rather than the branching patterns which normally characterize the surface streams. Number 3. It is not possible to explain by stream erosion the blind galleries found in caverns. Number 4. The general absence of graded longitudinal caverns profiles indicates the caverns have not been formed by corrosion by underground streams above the water table. Number 5. Many wall pockets or ceiling packets or ceiling tubes or other features unrelated to joints and bedding planes could not possibly have been made by streams that now through the caverns. The second theory, that is water table theory of Swinnerton. According to Swinnerton in 1929 and 32, the development of caverns is due to solution by Vadose water, and the solution takes place essentially at the level of the water table by laterally flowing water. The theory has been called the water table theory because of his emphasis on the lateral movement at the level of the water table. As the surface streams cut down and deepens their valleys, the lateral flow of the water at the top of the water table is accelerated. This movement of water takes place largely along the joints and bedding planes. Lowering of the water table with the lowering of the valleys is responsible for the formations of caverns at different levels. Third theory, that is invasion theory of Malott. According to Malott, based on his studies of caverns of Indiana and Kentucky in the USA, conducted over several years, that is C.A. Malott put forward a theory in 1937 which he called an invasion theory of caverns development. According to this theory, the water of the diverted surface streams which moves through underground water or underground roots is essentially responsible for cavern formation by the process of solution. He did not agree with Davis that the underground streams flow through caverns which already had been formed below the water table. Then coming to the conclusions. The importance of limestone reservoir in future years is likely to increase the other suitable sites situated on non-carbonate lithologies will become a progressively utilized. It is essential that the fullest possible pre-construction with particular references to part played by the secondary permeability of a fissure nature. Applied geomorphic studies of karst terrain are still very much at the empirical stage. In part, this reflects the lack of integration and sharing of experience between the workers in different fields concerned with karst landscapes and hydrology. Much valuable information has been gained from locally intensive studies of a civil engineering nature with the availability of borehole informations, but all too often such information is not readily available and it is very difficult to place the data in their regional context. Studies of groundwater hydrology tend to use models derived from Darcy's law, even in contexts where it is evident that the basic assumption of intergranular water movement under laminar conditions in a neat isotropic aquifer are clearly not fulfilled. The tendency amongst the geomorphologists has been to consider the differences between the varying types of limestones landforms are dominated by process variations linked to a climatic differentiation. Where we are considering about the academic knowledge of limestones, we need so much of knowledge about groundwater tracing methods and methods, which are the required technology about the dam and reservoir constructions and quarrying of limestones. Finally, we need a more academic and practice knowledge as well as the general informations and techniques for implied or effectively using a limestone areas. Thank you.